Looking at the first one, 5x to the power of 125. Whenever you're doing it by common base, you want to try to get both of them with the same base. Okay, so looking at this, can I rewrite 125 with a base of 5? Or another way to think of it is 5 to the power of what equals 125? Do what? 3. So I can rewrite that as 5 cubed. And if they have the same base, I just make an equation out of my exponent. Bless you. Now, you're going to have many problems where you will not be able to do that. You'll have two numbers where you can't have the same base, and so you'll have to do logarithm, fish hook, and solve it that way. If I was to fish hook this, where would I start? The what? The 5. So I would have log base 5 of what? Equals what? X. Okay. So then at this point you would put log base 5 of 125 in your calculator if we didn't already know the answer. Or if it's an easy one, you can just ask yourself 5 to the power of what equals 125. Some of those easier ones you could probably just do in your head. Some of these, by doing it by common base, is a little more difficult whenever you've got two numbers where one is... on the first one it was easy because 5 was already the common base and it was already one of the bases. But if you got two numbers where one of them isn't already the common base, you'll have to change both of them. These are a little more difficult. Okay? And it's just finding the common base they share. Because I can't raise 8 to a power and get 32, because 8 squared is already 64 and it's going to go up from there. But the base that these two share is 2. Okay, 2 cubed is 8. And then you would have to put x plus 2 in parentheses. Then 2 to the power of what equals 32? Two to the power of what equals 32? All right, let's see if we can figure this out. So 2 times... Thank you, Alexis. Alright, so I cancel those out. And then you would just solve this. So you'd have to distribute your 3. Subtract 6, divide by 3, and you end up with negative 1/3. Alright, it is these that using logs, or on this, this you would go to logarithmic. It's probably more efficient, it's probably easier than this. If I was to fish hook this, AJ, what would that look like?
Log of 8.
Log base 8 of?
Log base 8 of 32 equals x plus 2.
Okay. And then from here now we just have to solve for x. So what would I need to do? I don't add 2, but subtract 2. So, and here is, so which one of these is the correct answer? Oh, sorry. The first one or second one? Raise your hand if you think it's the first one. Log base 8 of 30. Raise your hand if you think it's the second one. Raise your hand if you don't know. Okay. Okay, that's kind of, yeah. So, after you fish hook it, this right here, that is the complete log. So do not put anything else into that. Okay, so that 32 is going to stay the same. The only way that you would change it is if you had another log base 8 of something that you could combine it with using the properties that we talked about previously. So this one, you would have log base 8 of 32 minus 2. So I want everyone to put that in your calculator and make sure that you get negative 1/3. That way you're good on putting this into your calculator, which, since that 8 is not a 10, how do you put that log in the calculator? Alpha window 5. Yes, Matthew. Let's look at 3. So I've got log base 3 of x equals negative 2. So because there's nothing after the x, that log is already isolated. An example of one where it would not be isolated is if I had log base 3 of x minus 4, I would need to add 4 to the other side. If that x minus 4, if that's all in parentheses, that log is isolated. Okay? So it is always the first term after log in the base, unless there's parentheses around it. Alright, so you need to get used to getting that log by itself. If there's anything after the parentheses, we need to get rid of it. If there's anything up front, we need to get rid of it. So, on 3 is pretty basic. It is by itself. Once I get the log by itself, I would fish hook that. Okay, and literally if I fish hook that, what is that going to look like?
That is going to look like base 3 is 3
To the power of
to the power of negative 2
equals
equals x.
x. Without putting that in your calculator, can anybody tell me what that's going to equal? Not negative 9. Not 0.1.
0.1 repeating, or 1 repeating.
No, because that tells me you put it in the calculator. Do what, Sierra? 1/9. If 3 squared is 9, 3 to the power of negative 2 is 1/9. It just makes that fraction. Okay. So let's come over to 4. If I have natural log, what does that mean my base is? That's common log. It's the not variable, but it's in apert E. Okay? So whenever you have natural log, this problem right here is the exact same. That natural log is the exact same as log E. Now you don't have to rewrite it. Okay? In fact, I wouldn't rewrite it. I would just put a little E telling me that my base is E. But with that being said, you're never going to see natural log base E. It's either log base E or natural log. Okay? So, is this log isolated? Yes. So, Cade, whenever I fish hook this, what's it going to look like?
I don't know.
What's the base? E to the power of
1
equals.
x.
Okay. Whenever you do that, it's going to be, if that's in parentheses, then it's going to be equal to that whole thing right there. And then AJ, how do I solve for x? Subtract 1. So everybody do E minus 1. How do I put E in my calculator? Second divide. Was that you again, Alexis? Sure it wasn't.
Wait, do you just type in E minus 1?
Yep.
So like
What'd you get?
1.71?
Let's do, whenever you're doing your decimals on this, let's do 3.
1.72.
1.718. Let's do 3 decimal places. Okay, so now let's go down to 6. Alright, Ryan, on 6, what is the base?
1/3. 6.
6. What is it being raised? What is the exponent? Negative 4x. So, I need to get that by itself. So what's the first thing I need to do? Subtract 1. So that's going to give me 1/3 times 6 to the power of negative 4x equals 5. How do I get rid of 1/3? Multiply both sides by 3. Once I'm there, can I fish hook that? Yes. Paulina, whenever I fish hook that, what is it going to look like? What is the base? No, looking at this right here. 6. So log base 6 of equals. And then how would I solve for x? Yeah. Just look, just by looking at that, how do I get negative 4 off of x? Divide by negative 4. So I want everybody to put that in their calculator and see what they get. Okay, don't make it any more complicated. The whole thing's a fraction, so I'd do alpha y equals first. Then you get a log, alpha window 5, and now it's set up. You just go through and put everything in. And Noah, whenever you did that, what do you get? Fabulous. Okay. So next, I want you to go through the rest of those problems. I want you working through those. Let me know if you're struggling with it. Please help the people you're sitting next to. I'm going to scroll up. I'll put the problems that we just did up here. I'll put those back up here. And I'll just be a couple minutes behind you. Okay, so on 5, even though it's E, don't think that you automatically have to start putting natural log, because a lot of people get mixed up. Anytime you fish hook, I would just do log, not natural log, and then go from there. So I would have log base E of 3.23 equals 2x. Then at that point, if you want to replace log base E with natural log, that is what it would look like. Because these two things, those two things right there are interchangeable. Log base E and natural log. Okay? You're not going to have natural log base E. That doesn't, you won't have that. Alright? And then from there, you would divide both sides by 2. And you should get that x equals, I don't know, whatever it is, 0.586. Okay. Okay, looking at 7. So because that has parentheses, the log is isolated already. It's by itself. So I'm going to start on my base. 4 cubed equals 5x minus 1. Now, something that some people, especially last class, struggled with, and I can see some people might be headed down that road in here. Whenever you have something like this, and some people don't like to deal with this, go ahead and write what it equals. Okay, because last class I had some people trying to add 1, and they did 4 to the power 4. They added 1 to the exponent, which you don't want to do. Okay, so if you get that, go ahead and change 4 cubed to 64, because that's what it equals. Then add 1, divide by 5, and you should have gotten that x equals 13. Okay, so looking at 8. On number 8, I've got something in front of the log that I need to get rid of. How do I get rid of that 1/2? Multiply both sides by 2.
Oh my gosh. Bless you.
If it is natural log, what is my base?
E.
So I'll have e to the power of what?
8.
Equals. And then how do I get x by itself? And Jackson, what did you get on that one?
993.
Oh, that's a really big number.
Okay, so on 9, is the log isolated right now? On the left side of the equal sign. What do I have to move first? I got to add 3 to both sides. And then some of these, okay, remember how, just how log works. This is probably, you can probably do this in your head. 3 to the power of 1 equals what? 3. So x equals 3. On 10, we're going to talk about inequalities on the back a little bit more with word problems. If you got 16, you did it right. That one's pretty simple. We're going to go ahead and go to the back and work through these word problems. Okay, so looking at this, it says Jack bought a car for $24,900. It depreciates at 11% per year. When the car falls below $10,000, he plans on trading it in and buying a newer model. So let's go through this table. It's a little tedious, but let's go ahead and fill it out. So whenever he bought it, and it was 0 years old, the value of the car was $24,900. And then if I wanted to find how much it was worth after 1 year, what could I do to that value?
Multiply by 0.8.
0.89, because it's depreciation. You do 1 minus 0.11, and that's going to give you 22,161. And then you would just multiply the previous year, the value, by 0.89 each time to find the next year. So go ahead and finish that table out for me, please. Okay, so as you're filling that out, this is pretty tedious, but I've seen similar work on tests and quizzes where you don't really know how to use the equation, so you sit there and you multiply it by 0.89 and see if it drops below 10,000. And you do it again, then you do it again, and by the end of it, I'm grading something that has a table that goes all the way down the paper, and it's very long and it's very tedious. So that's one way that I've seen it worked out. People who have known how to do the equation says write the equation that describes the car's value, which I have it right there in the last row in that middle column. Okay, in terms of time. And then it says write the inequality that describes when the value of the car is less than 10,000. So I would have that same equation, and I want to know when it is less than 10,000. Okay, now, how have we solved those problems in the past? Previously, how have we done those? AJ, don't look at me like you hadn't seen a problem like this. Do what? Okay, you can put in y1, y2 and do what?
Go to the graph.
Okay, you can go to the graph, and then you can adjust the window 84 different times so you can see the intersection, and it still takes quite a while. Or you can go to the table, and for the sake of time on this one, whenever you go to the table, you find that it's somewhere between 7 and 8 years, which I told you a few weeks ago. I do not want answers like that because that is too broad of an answer. So using logarithms is, I think, a more efficient way than both of those, and doing something like the table to solving this. So if I have the equation, let's just do what I have up there with the inequality, except let's put equal instead of less than, just for the sake right now of minimizing confusion. And I'm going to do logarithms, and the process to do this is the exact same as it was on the front. It's just now the base is a decimal and the numbers are a little bit bigger, but it's the exact same. So if I wanted to solve for x by using logs, what's the first thing I would need to do before I can do that? Because I have to isolate the base and its exponent.
Oh, you divide it by 2.
Divide by the 24,000 number. Okay, so I end up with 0.89 to the power of x equals 10,000 divided by 24,900. And then after I've done that, Jonah, whenever I fish hook that, what is that going to result in? What's that log going to look like? What is the base? What is being raised to the power of x? So log base 0.89 of you want to do that whole fraction. So it's the 10,000 over 24,900 equals x. And then you just put that log in there. Okay? It's not a complicated log to put in. It's very similar to what you've already been doing. The base is a decimal. Hopefully you know where the decimal button is on your calculator. Alright, whenever you get to here, it's a fraction. So do alpha y equals. Or you can just put 10,000 divided by 24,900. Just make sure that it's all in parentheses.
Could you solve for 10,000 divided by 24,000 first before you put it the other way?
you can, but the thing is if you do that, so do that real quick. If you didn't hear AJ, she asked, can you figure out what 10,000 divided by 24,900 is first, and then put that in there, which, what does 10,000 divided by 24,900 equal? Do what? Okay. So 0.4016064257.
Inaccurate.
But if you round that, you're changing that number. If you put the actual fraction, you're not changing the number. So if you use the fraction, your final answer is going to be more accurate. Because you're dealing with exponential stuff, the difference between using the fraction and using a rounded decimal, the difference in your final answer is going to be magnified a lot as opposed to other stuff we've done. So it is much, much safer to use the fraction than it is the rounded decimal. So whenever you do this, you get that x equals what?
7.282 years.
828.
Yeah.
Okay. Now let's put the correct inequality in there. And so kind of get your mind back into the word problem where you're talking about a car and the older it gets, the less the value goes. So what inequality would make sense in this answer? Do what? Greater than. Okay. As the car is older than 7.8, when the car is 7.828 years, it's equal 10,000. And then once that age gets bigger, once x gets bigger, the value drops below 10,000. Alright, so let's look at the next problem. Says, suppose 4,000 in principal, okay, principal is the same as initial value, is invested at 6% interest, compounded continuously. So, Ryan, what formula are we going to use? APERT. And it yields, or the final amount is 5,333. Or you're going to use APERT on this. Okay, so again, it yields 5,000. The 5,000 number, that's the final amount. My initial was 4,000. And then it's E. My rate is 6% times time. And we're finding how long it took for that 4,000 to turn into 5,333 in this account. So what's the first thing I need to do here? Isolate the base and exponent. What is my base and exponent, AJ? So how do I get that by itself? Fabulous. So I'd have 5,333 divided by 4,000 equals E to the power of 0.06x. Alright. Erica, whenever I fish hook that, what am I going to get?
You're going to do log,
Log base E of,
would you do the fraction?
yeah, because whenever you start on your base, and this is kind of, I wrote it backwards like this. You start on your base, and I don't want you to think that you always go to the right first. You always go across the equal sign. So it would be the 5,000, the fraction. And what's that going to equal?
0.06
And then Lily, how do I solve for x?
Divide by 0.06.
So now I want everyone to put that in your calculator. Let's see what you get. The whole thing's a fraction. So start by doing alpha y equals. Get the fraction. Then you go to log. Alpha window. Alpha window 5. Or, what is the same as log base e?
L actual log.
So you could do ln.
Coach Howard, you created the note. Is number 13 is terrible.
Oop. We're not going to solve the second part of this. We're not going to go through the whole process, but I do want to talk about it. Whenever it says, when the original, it also says, when will the original deposit be doubled? Okay, so if the original deposit was 4,000, if that doubles, it's 8,000, correct? Don't start all the way at the beginning and put 8,000 right here and do all the exact same steps over. If you've already got it solved for, put 8,000 right there and just put that in the calculator, and that will give you the answer for that. Okay, so next, get the yellow sheet that you picked up on the way in. We're not going to do the last two problems.